Okay, so we're going to do another vectors application problem in 2 dimensions here. And we have a harbor that's located at the origin. So down here is where our harbor is. And we'll call this down here as O. And the rock is located at 1013. So roughly about right there. There's my rock at A. And it's 1013. The sailboat leaves the harbor at 9 o'clock and travels at a constant velocity 4-3, measured in kilometers per hour. P is the position of the ship at time t, where t is measured in hours. So I know that OP is the position of the ship, and I know after 1 hour, if I go over 4 and up 3, this is where the ship is in 1 hour. If I go over 4 more and up 3 more, that's where the ship's going to be in 2 hours, and so on and so forth. And so the ship is going along this trail here. Okay? So if I want OP and AP, well, OP is simply the vector going to be right now, currently it is T 4 3. This P changes with time. So that's OP. If I want AP, well, AP is this vector here, AP here. I go head minus tail, so I'm going to take P, which I can say is T 4 3, minus A, which is 1013. And so my vector AP, if I put it together and change things around, I get negative 10 plus 4t and negative 13 plus 3t. 3t. That's vector AP. When t is 1, OP is here and AP is going to be this one. And if I change my t, I'm going to get various points on this line. T gets large, it's going to get closer to A. Smaller, it's closer to O. So if I want to find AP at time t, well, that's this one right here. This is AP at time t. So this is the answer to part B. Then it says, correct the nearest minute. When is the ship for the first time 15 kilometers from the rock? Well, this distance here is the distance away from the rock. So I'm going to call that D. So if I want to find the D, that's the same as the magnitude of this vector. So D, that distance, is equal to the magnitude of AP, which if I do that is the square root of minus 10 plus 4t, all squared, plus minus 13 plus 3t, all squared. And I want that to be equal to 15. To solve this equation, I have lots of options available to me. Probably the easiest option is to graph it. Use your calculator, graph it, find the point of intersection. For me, I'm going to use Wolfram Alpha since it's easier to do on the computer. So let me call up Wolfram Alpha and we will get a value for... Okay, so we paused there and did some calculations. We threw this into Wolfram Alpha. Here's our equation. We solved it and we got these two values. And specifically it's saying correct the nearest minute, when is the ship the first time 15 kilometers away? Well, that's going to be the 0.29196. I need to put it in minutes. This is in hours. So if I take the 0.26...
Wait, how do we know it's in hours?
It says so in the question, 0.291969 times it by 60. Oh, it said 17.5. And so it says, excuse me, it says the time is 17.5 minutes to the nearest minute. If I just double check that, that's going to be 18 minutes. So this is equal to 18 minutes. If it's after 9 o'clock, this is at 9:18 is when it's closest to the rock. So it's not actually going to, it's not going to hit the rock. It's going to pass by something like this. Here's one time it's close, and then another time it's 15 kilometers away. Okay, so that is C part. the time. D part says find as a function of t the scalar product of those two. So I take this vector's AP, which is negative 10 plus 4t, and negative 13 plus 3t. This is D part. And I'm going to dot product that, or scalar product that, with the vector 4, 3. It says just do it. So when I do this calculation, I get 4 times negative 10 plus 4t plus 3 times negative 13 plus 3t. Simplifying that, I get negative 40 plus 16t minus 39 plus 9t, which is then minus 79 plus 25t. That is my scalar product in terms of t, a function of t. Then it says, using part D, find correct the nearest minute when the ship is nearest the rock. Well, if I want the ship to be nearest the rock, it's going, if I clear up this diagram a little bit, my ship is going on this path here. Here's 15 kilometers away, here's 15 kilometers away. The closest path is when it's perpendicular. So if I want it to be perpendicular, that means the dot product has to be equal to 0. So I set the dot product, minus 79 plus 25t, equal to 0. Solve for t, I get 25t is equal to 79. And so t equals 79 over 25. And again, that is in hours. So 79 divide 25 gives me 3.16 hours. And if I change that to minutes, well, this is 3 hours. I'm going to multiply the 16 times 60. 16 times 60. Oh, make it 0.16. 0.16 times 60 gives me 9.6. So 3 hours after 9 o'clock is 12. In the nearest minute, that's 10 minutes. So it is closest to the rock at 12:10 because I started at 9 o'clock. Here's the starting time, 3 hours and 10 minutes later. So there's a lot of conceptual stuff here that you need to hold on to. Dot product equaling 0 means it's going to be the shortest distance or perpendicular. And the distance set equal to 15 for C part.